Hi, my name is Rebecca Lee, and this is our presentation on cloud computing. In the world today, technology continues to advance at an exponential rate, and as software developers, we must come up with new services and concepts to help technology prosper in its growth. This is cloud computing, a service that caters to the public by making software development as efficient as possible for the lowest cost possible. Cloud computing requires three parts: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, or IaaS, is the infrastructure in the cloud computing stack, known as the system layer. This is a cloud service model consisting of servers, storage, and networking. It compiles services in an easy to access virtualized infrastructure instead of physical ones that would be used in the traditional software development. Consumers are free to manage the underlying infrastructure, and they have more control over software-related resources such as operating systems, storage, deployed apps, and networking components such as host firewalls. IaaS is a beneficial model as it manages your entire application and third-party solutions while removing the physical hardware and data centers. It heavily reduces the cost of buying physical devices, storing them in data centers, and having to employ IT professionals for maintenance. It provides an easy and quick setup of backend operations, and it provides more scalability, eliminating concerns of physical limitations through the virtualized environment. An example of IaaS would be Amazon's Elastic Compute Cloud, or Amazon EC2. This service promotes on-demand computing capacity through a web service interface, and it gives the user the ability to create an unlimited amount of virtual instances. The consumer would only have to pay for the amount of capacity that they need or use. They even give you the choice of processor, storage, networking, operating system, and the purchase model. IaaS serves as the foundational layer of cloud computing, and because of that, it is very important because a lack of security can affect the system as a whole, affecting the other delivery models in the process. One of the key technologies that IaaS uses is platform virtualization, and it uses a hypervisor to run one or more virtual machines simultaneously, preventing access to other virtual machines' data. This is a technology that protects the data of the company, and it is the reason why we need so much security at this level.
Okay, so the next layer in cloud computing that I'll be talking about is PaaS, which is Platform as a Service. It's basically a cloud computing service that uses virtualization to provide the user with computing platforms such as an OS, programming languages, and executable environment, databases and its features and functions, web servers, and the ability to create applications which developers would enjoy doing so. One such example of a platform as a service is Microsoft Azure. It's basically a public cloud computing platform provided by Microsoft that offers these same solutions such as virtual computing and storage capabilities. One of three ways that a platform and service can be deployed is through either the private cloud, the public cloud, or the hybrid cloud. So, touching upon Microsoft Azure, it's mostly used by business organizations in scenarios where developers want to use the development framework. And the good thing about PaaS, or I guess in this case Azure, is it lessens the coding workload. It lessens the how much the developer has to work on the stack, and the PaaS just basically does the work for you. And this way, it allows developers to use most of the inbuilt software components. Just like I mentioned right now, it does handle the OS workload, allowing developers to fully focus on building their applications for the end users. So, wondering if you're a company and if you're wondering why you should establish or bring in PaaS is It's very cost effective. One trouble companies face is how much hardware they have to purchase, how much things they have to install. But in this case, PAS lives in software, and no hardware is required at all. Another good thing is it provides virtual data centers, which allows companies to dynamically scale how much storage they would like, how much database resources they'd want to put in to their servers. And it comes with almost no to little downtime. As it is software based, team members can basically work anywhere. Users can work on apps anywhere they want, whether it be at home, the company, or wherever they may be. It has speed to market, which just speeds up the creation of apps, allows developers to focus, as I mentioned before, on the inbuilt stuff they want to make. It has custom solutions. It has tools embedded into the package for developers who want to create custom software. Now, the way it works, unlike SaaS, which is software as a service, which touches upon the company's entire IT infrastructure, PaaS only just touches upon the key services with minimal startup costs and reduced deployment times. It solely works and runs in the software field, as I mentioned before, and dynamically scales and allows for great computing power, depending on the computer with the processor you are using. Team members who are distant from each other geographically can also collaborate in a development environment. Now, the downsides that come to PaaS is if a user or if organization ends up using it, they almost have no hand, hands-on hands-on capability of dealing with a faulty service or something that may not be working, since only the PAS provider can start working on that, which is brings up the idea of depending on the PAS provider. And when you're depending on them too much, it could hinder company time, efficiency, and all that. It also comes with the security risk always are an issue, whether what software or hardware you purchase, because at the end of the day, you are trusting a third party, and by that provider, you don't know if they have poor security practices or not. So it's up to the company to make a efficient decision on what kind of PAS they're going to buy from which vendor they want to purchase from. Another issue that comes arise is compatibility issues. Let's say a company has already their own installed custom software. How will that software interact with the PAS and its features? It may hinder the ability of the company to use that software, to use their own, or maybe even the PAS at all. And yeah, that's about it for my part.
Hi, my name is Harold Vintayan, and I'm doing my section on software as a service. So, software as a service is the last layer of cloud computing. It includes both IaaS and PaaS to bring the whole product together. It's something that's efficient for everyone who uses the cloud, allowing application-specific parameters and the ability to manage users. It's said that the applications are accessible from various client devices through either a thin client interface, such as a web browser or a programming interface. That basically means that it can be used everywhere, not just the web browser. So it's very versatile. So the reasons for using software as a service. Firstly, it provides infrastructure support, maintenance, and support in the process of hiring and managing staff. Software as a service allows the consumers and the service providers to benefit, giving revenue to vendors for improving their application, as well as the service providers as well. It gives reason to keep contributing to the application on both sides, so that users are able to spend less while quickly scaling their business to the size that they want. Software as a service is mainly comprised of three layers. The first layer is the data access layer. The data access layer handles all the processing requests, and it allows data to be stored and manages the data in its database models. The next layer is the network layer, and it handles server communication of the application, and it usually checks for faults in the system and manages the traffic coming in and out of the server. The third and last layer is the vital security layer, and it allows authentication, authorization, and monitoring solutions to happen. So basically, you're able to know what's going on in your application and who is doing what at all times. So, software as a service is vulnerable as it stores data through third parties between providers and consumers. Data is spread out among many users, so it's easier for it to be exploited and the data to be stolen. For example, SQL injection attacks can allow hackers to gain access to information, and doing so can lead to other databases of information be stolen as well. And we still have to be careful of when the subscription ends, because when data is erased, it can still be stolen as it may not be completely deleted. Software as a service is also vulnerable with the way that it transmits data through third parties. With the amount of packages that are transmitted through servers, it can fall victim to lots of attacks. For example, DNS attacks, man-in-the-middle attacks, IP spoofing, port scanning, and sniffer attacks. Information across databases also has to be updated every time a transaction happens. So it's always taking up bandwidth from running security measures like checksum or error checking algorithms. The use of these algorithms takes up a lot of space, and this overuse of resources can overload the system, and it creates a big problem for the service provider companies that are holding these cloud computing services, which is the reason why we have to always monitor the application.
So this is issues with data security, and one of the main issues that comes with data security is the regulatory compliance and respective storage by providers. What that means is that, well, what regulatory compliance is when a business follows state, federal, and international laws and regulations relevant to its operations. Basically, the provider has to comply with the law and with a user's privacy. And if they don't do that, then they can get actually into legal trouble, which is really bad. And one of the solutions that can come to this is actually that the providers can offer services within location tags, which means that each user would get a specific geographic location so that the provider wouldn't have to focus on everything. This is good because it would make it so that the providers would comply and they wouldn't get into legal trouble, and the users would feel better about their information. Another issue has to do with data erasure, and in this case, users are unsure of whether or not their data is being completely deleted. And obviously the problem with that is like they're concerned with their privacy and like things like this, or they're thinking that the company is like saving all their deleted data, and that's also a problem with the provider too, because they're always unsure too, like whether they keep it. But a solution to this could be cryptographic erasure, which is actually one of the forms of data sanitization. And basically what it does is, like while the data remains on the storage device itself, if you erase the original key, the data is actually impossible to decrypt, which means that you can't recover the data, which means technically that you have deleted it completely. And sure, it's not actually completely deleted because there's still the data there, but it can't be decrypted, which means that it can't be touched and no one can touch it, no one can do anything with it. It's just gone basically. But there are pros and cons to cryptographic erasure, and that should be covered right now. So the first pro to cryptographic erasure is actually that it's faster than overwriting, which is really good because one, that means that it's not something that's being done on like an actual device, which is the other thing for it's devices keep their original integrity, which is good because it's part of cloud computing. You know, like the devices don't have to worry about data management as much. Data sanitization is a lot easier, especially when it comes to cryptographic erasure. But there are a bit more cons. It's hard to implement cryptographic erasure, which is really unfortunate. And there's always human errors when doing this. And there can be backups for crypto erase keys. Alright, thank you very much.